And some of the things that are unique about this is the operation of these joints in space and at such a cold temperature. We do have a few heaters that we warm up the motors and some of the mechanism components, but for the most part, the joints have to work in the cold environment of space, which takes special design and special coatings. And as you can see, they also are quite close to our mirrors, so we have to be careful about contamination. This is also the first time we had to do this deployment in zero gravity. Every other time that we've done the deployment in a clean room, we've had to have gravity considerations. So this is the first time doing it in zero gravity.
We were talking about that yesterday with the non-explosive actuators, all of these little pins that need to release to unfold different parts of the telescope. And again, those were all tested on the Earth, where you were not in zero gravity. They needed to work in space. And Julie, I don't know about you, but every time I see that mirror move a little bit farther in our visualization tool, I'm getting more and more excited. My heart is starting to beat faster and faster. For me, there's a tremendous amount of joy. I mean, I have this smile like on my face from ear to ear right now, as I see this absolutely essential component of the James Webb Observatory, the secondary mirror, the focusing mechanism deployed.
Yes, without this mirror in its right position, we do not get light into the telescope.
And all of those actuators, all of those pins that needed to release in order to unfold this. Julie, can you give me an idea? I believe there's are there over 300 of those?
Yeah, there's different kinds and different types around. So it's kind of every time you'll read something, it will tell you a slightly different number, but it all depends on what category they count them in. And for this what we watched today, there was 3 different ones that we released. So there is so much of that now behind us. There was a lot of work over the years to make sure that these devices worked, and then all the different configurations that we needed them in and the different sizes to make sure that they all worked and they all worked reliably. They're very much like a parachute. They're very sensitive to how they're wrapped and how they're handled. You get one chance to do it right, and if you test it and it works, that doesn't mean that you've done the next one right. So you have to package each one just perfectly. And we're coming very close to being fully deployed. As you can see, the top of the mechanism, the 2 bars there, coming closer and closer to their final position of being in line with each other. And you can, from this orientation, you can now see that the mirror side of the secondary has the gold coating on it too in the visualization tool.
Well, the Webb Observatory is a very large mirror. It's a tiny amount of gold. I believe it's just a couple gold rings worth of gold across the whole thing, just a couple 100 atoms thick on the surfaces. Yep. Gold was chosen because it is wonderfully reflective in the infrared. This is a heat-sensitive telescope, infrared light. And also gold is very stable and doesn't, unlike something like silver, doesn't react chemically very much. So it's a very good thing to use when nobody can go out there to clean your mirrors. It's all on its own.
So as the mechanism continues to unfold here, the motor will drive it into a hard stop. And from that, then they will start working on the latching procedure.
So we will first wait for confirmation that the mirror is fully deployed. And then after that, as they go through the latching procedure, we'll have some time to talk to our host a bit about the testing and the building of the secondary mirror. We already have a lot of questions coming in through social media. We should have time to get to some of them. But if you'd like to have your question answered, just go to #AskNASA.
And we have deployed into the hard stops. So we'll move into capturing the latches and then recentering.
All right, as you heard, that went completely into the hard stop. And they'll take a little bit of time. to take a look at their telemetry, put the motor into a standby mode, and then move into the latching sequences.
So, Julie, at this
Actually,
point, the mirror.
they will keep the motor at this point. I'm sorry, I misspoke. They will actually keep the tension on the motor at this point while they do the latching.
So as they are starting latching, I think so. At this point, the mirror mechanism has been fully deployed. Is that correct, Julie?
Yep, the mechanism is fully deployed. The motor is holding it to the hard stop while they do the latching.
I have confirmed with the step lead that we are ready to proceed with the ADU latch moves. So at this time, we are going to proceed onto step 044 to enable SES 256.